you are designing any kind of a circuit. You are going to design any kind of a circuit. This circuit requires various kind of gates. Those gates we call it as logic gates. And whatever the concept that we are trying to learn how to use these logic gates, we can call it as logic design, right? The way you are going to arrange these gates to get the efficient output, all those things we can call it as logic design, right? So once we know the how to design these gates, that if you are going to yield certain kind of outcome, and that entire thing we can call it as a circuits, right? If you open if you take any kind of a chip, or we can call it as a memory, or any kind of motherboard, where internally it contains various kind of circuits, right? These circuits all will contain the logic gates. So now we'll discuss various kind of logic gates which are available for us. Like for example, let us take the first kind of logic gate is AND logic gate, which is meant for when you are going to give uh, two inputs, those two inputs should be true, then our result will be true. In all the remaining cases, our result is going to be fail, means our result is going to be false. I mean, when both inputs are high, then only my result will be high. In all the remaining cases, my result will be low. Like if I take it as a parameter 1, input 2, and my output, right? This is thing, right? For example, instead of taking input, I can take it as A, I can take it as B, output I can consider it as A dot B, simply, right? Yes, when both inputs are high, then only my result will be high in all the remaining cases. See, this one represents basically as true or high, right? I can call it alternatively in this subject. 0 represents false or low, meaning that when both inputs are having high voltage, then I can get the output as high voltage. When any one of the input has low voltage, I can get the output as low voltage. So the symbol for this AND gate is, you have to use this symbol. Okay, basically this is what we can call it as two input AND gate, right? So if you are going to give A and B as input, you are going to get the result as A dot B, A dot B. Okay, fine. This is one kind of a gate. And another kind of a gate is OR gate. Like if you are going to give two inputs A and B, both are going to range from the values 0 0, 0 1, 1 0, 1. I hope you know, right? Here also you have to write in order. So for to make it clear, right? Your output will be A or you are going to represent in the form of plus symbol, or ARB. So 0 0 0 0 1 1 1 0 1 1 1 1, meaning that when both inputs are low, then only my result will be low. In all the remaining cases, your input will be high. So the symbol for this is something like this, A or B. When you are going to give two inputs as low, your output will be low. In all the remaining cases, your input will be high. Okay, assume that here I am going to give the input as 1, here the input as 0. What is this symbol represents? OR gate, right? OR gate is going to do what? It is going to perform OR operation over the two inputs A and B, right? 1 plus 0 is what? Right? Meaning that when one input is high, another input is low, the output will be high. So your result will be, this is the meaning of OR gate. Okay. Next one is a kind of a basic gate like NOT gate, meaning that when you are going to give one input, it is going to produce its output in opposite form, that is A complement, right? When you are going to give input as 1, your output will be 1. When you are going to give input as 1, your output will be 0, right? we can represent. So this NOT gate is going to take 1 as input and its symbol like this. If you are going to give A as input, it is going to produce A complement as output. This is what the meaning of NOT gate, right? See guys, here every time I'm trying to discuss only two inputs. It's not only about two inputs. We can have a gate with n inputs also. So this is what I can call it as n input AND gate. Okay. Similarly, if you go with like this, we can call it as n input OR gate. What is the meaning of this one? For example, this is A, B, and so on. What is the meaning of this one? A dot, B dot, C dot, and so on. What is this one? A plus, B plus, C plus, and so on. Right? This is what the NOT gate is going to take only one as input and it is going to produce one as output, that is in the form of complement form. Right? Okay, fine. Next kind of gate is NAND gate. NAND gate, right? So NAND means, if you observe here, it is simply like a combination of and not. It is combination of and not. Okay, means if you observe, if I try to draw this one, I can call it as a truth table. Right? I hope you have the idea of discrete mathematics, where you will come across this point, this table again, right? So and not, right? Meaning that, so what is like here observe how we are going to write the AND gate. AND gate is something like this. For this AND gate, you are going to get output. For that output, you are going to produce again NAND gate, right? When you are going to give A and B as input, here what is the output you are going to get? A into B you are going to get as output, right? If you are going to complement this, your result will be AB whole complement. So the NAND gate defines AB complement. AB complement. Okay guys, so for this alternative, we can be able to represent as like this. This is also we can call it as NAND gate, right? So means, if you are going to give two inputs 0 0 0 1 1 0 1 1 as input, the truth table contains actually AB. AB means what? AND gate. AND gate is what? 0 1 1 1. So coming to NAND gate, that is AB complement. What is AB? 0. AB complement is what? 1 0 0 0. Means when both inputs are low, then only my result will be high. When both inputs are low, then my result will be high. In all the remaining cases, my input will be completely low. That is the meaning of NAND gate. Okay, fine. Next kind of gate is NOR gate. NOR gate is simply OR gate plus NOT gate. See, I will tell these advantages later part. For time being, try to understand the basics. OR plus NOT. So how we are going to write the OR gate? Simply OR gate. OR gate. If I am going to give input A, B, your output will be A plus B. For this input, I am going to attach NOT gate as input to this circuit. So you are going to get A plus B whole complement. So NOR gate I can call it as A plus B whole complement. Okay, fine. So what is the truth table for this one? If you are going to take 0 0 0 1 1 0 1 1 1 1 and this is A B, your truth table will be basically, if you are going to apply OR gate, that is A plus B. So 0 for when both inputs are low, your output will be low, and this all will be high. Actually this is OR gate, but our requirement is NOR gate, right? NOR gate means what? A plus B whole complement, right? So 1 0 0 0 0 0. Okay guys, here in the earlier NAND gate, I made a mistake here. When both inputs are low, your AND gate produces 0 low, and here also will be 0, here also will be 0. You have to make sure that, right? Meaning that AND gate means when both inputs are high, your result will be high, and all the remaining case your output will be 0, right? So what is the complement of this one? So complement of this one is 1 1 1, right? So means when both inputs are high, our result will be low, and all the remaining case our output will be high. Whereas coming to NOR gate, when both inputs are low, our result will be high. In all the remaining cases, result will be low. That is the property of OR gate. Okay, fine. Another kind of gate is there, that is XOR gate. XOR gate. Okay, so this XOR gate, you are going to basically define, represent it as like this. This is what XOR gate. You are going to give A and B as input. You are going to get produce output. So means here try to observe, when both inputs are same, means when both inputs are low, when both inputs are low or both inputs are high, your result will be 0. In all the remaining cases, your result will be high. Okay, fine. So this is the meaning of XOR gate. Okay, so they will be represented like this, right? So guys, if you look into XNOR gate, XNOR gate, XNOR gate is simply a complement of XOR gate. For this, we are going to place like this, right? If you observe here, 0 0 is input, 0 1 1 0 1 1. What is like XOR gate? See, observe here. So what is the resultant? You are going to get this one, right? So basically, result as, or if I take this is 0 1 1 0. What is the complement of this XOR? We get XOR, XNOR 1 0 0 1. This is the equivalent value you are going to get for XNOR, meaning that when both inputs are same, your result will be high, and all the remaining case result will be 0. Right? See guys, so if you are able to solve this particular equation, if you are going to solve this particular equation, you will get the result as A bar B plus B bar A. A bar B plus B bar A. Okay, so how we are going to get that, we will look into later part. For time being, try to understand that this result will be like this, XOR representation, right? A bar B plus B bar A. See, if you want to understand the meaning, for time I will explain here. You may understood, right? A bar B means what? I am trying to select 1 and 1, right? This is what? 0 means what? I am trying to take it as A B. A bar B is 1, or 0 plus means what? Or B bar A. That is the meaning of this one, right? This I can technically write it as A XOR with B. A XOR with B. Similarly, A XNOR with B. XNOR with B, right? See guys, if you are going to observe the complement of this equation, A bar B plus B bar A complement, you are going to get XNOR. You are going to get XNOR, right? So X plus Y whole complement is X complement dot Y complement. You may remember this equation. If not, don't worry. I will tell that later. If you thought like this is X plus Y whole complement, that is X bar dot Y bar. B bar A dot Y. Okay, right? X dot Y whole bar. Then X bar plus Y bar. A bar whole bar plus B bar into XY whole bar. X bar plus Y bar. B bar whole bar plus, right? Which is like A plus B bar dot B plus A bar. A plus B bar dot B plus A bar, right? If you are going to solve this equation once again, once again, like if you are going to perform multiplication towards each and every equation, you will get AB plus A bar plus B bar plus B bar A bar, right? So if you are able to observe, this is AB, these two is going to be cancelled out, A bar is 0 and B bar is 0, you are going to get B bar A bar. So the XNOR equation is AB plus B bar A bar. What is the meaning of this one? If I am going to write this equation, that means that 1 I am going to include it, right? So 1 means what? How you got A, B, and B bar A bar means what? This one. Okay, fine. See how you understood, right? Here I have taken this 0 as A bar, but here I have taken this 0 as A. You may get confusion, right? Right? Or else try to check, this is A bar B bar, and this is AB. This one I can write as A bar B bar, and this is AB. So that's the reason you are going to get the equation like this one. Right? Take out this one. This one is A bar B, and this one is A B B. Right? If you are going to perform OR operation, you will go. So meaning that XOR operation you are going to take as outputs 1. This is the meaning of XOR gate and as well as XNOR gate.